So sometimes students struggle with identifying what the bases are in a prism. Let's make sure that we're clear on the vocabulary. Notice in your notes that the bases are the congruent and parallel bases. So if you're looking at a prism and there's a bunch of rectangles and then there's two other shapes, those other shapes that are congruent and parallel, I like to think of them as the odd men out. They are the bases. Whereas all of your lateral faces will always be rectangles. Okay, so in problem 1, we're going to find the surface area of this prism by, as hopefully you've already done, kind of mentally cutting it open, laying it flat, and finding the area of all of its faces and adding it together. Now the way that I'm going to draw this net is in a way to kind of naturally lead into why the formula does what it does. So bear with me if your net doesn't look exactly like mine. The way that I'm going to draw my net is by cutting it up along the height of the prism and then unraveling its lateral faces. So here's what I mean by that. There's the front of it. It's 10 by 5. Here's the right face of it. It is badly drawn, but you get the idea. It is 4 by 5. There's the back. It is also 5 by 10. And here's the left face of it, also measuring 4 by 5. Okay, so I've unraveled the lateral faces, and I'm just going to flip open the top above it and the bottom below it. So let me throw that up here and here. Once again, on your notes, if you sketch the net differently, you're probably just fine. The main things that you want to be mindful of is remember that the number of faces in the polyhedron is always the same as the number of faces in the net. Okay, so if you're looking at 5 rectangles, that's incorrect because we have 6. Make sure that you have all 6 faces represented. All right, so the top and the bottom, once again, will be 10 by 4. So this one is also 10 by 4. And as I mentioned before, the way that we're doing this problem is kind of long and drawn out in the sense that we're opening everything up, finding the area of all of the pieces, and then we're going to add it together. Well, all of the pieces add up nice and neat because they're all rectangles, and the area of a rectangle is always just base times height. So this is 50 and 20, another 50 here, another 20 here. This is 40 and another 40. And when I add them all together, I have 100, 220 centimeters, and before I write it down, what do you think it is?
Square.
Is it square centimeters? Is it cubic centimeters? What do you think? No, it's not the number 4. Your sound split. And it's a common misconception that because this is a 3-dimensional figure, it would be cubed. Cubed is a volume measurement. That's what we'll be doing after break. What we've done here is found the area of a 2-dimensional figure. Notice, it was 3 dimensions, but we flattened it out. Now it's 2 dimensions. We found the area 2-dimensionally. Okay, so your answer is going to be in square units. Be very mindful of that.
So if you found it without picking it,
It would still be area, and area is still a square unit measure. Okay. So I made a big deal about how I drew it in a particular way so that it would kind of naturally lead into how we're going to come up with this formula. So what I want you to observe is you have it in the notes in front of you. I want to refer to it as I'm still looking at this diagram on my screen. Okay, so kind of bear with me with that. So it's asking you in your notes to notice that the part of the net drawn consists of the lateral faces. I'm talking about this part of my net. This is where I took my three-dimensional figure and I cut it open and I said I was unraveling the lateral faces. Well, look at that black, oh, I almost gave it away. What kind of shape is that? It's not a square, it's a rectangle.
Is it a rhombus?
It's definitely not a rhombus. Okay, it's a rectangle. And we know how to find the area of a rectangle. The rectangle is base times height. So think about it. Look at this black rectangle that I've highlighted on the screen. Look at where it came from in the original figure. The base of that black rectangle is what, as far as the original polygon is concerned? Let me ask it a different way. Let me ask it a different way. Look at what the base of this black rectangle is. It's 10 plus 4 plus 10 plus 4. Look, I'm not interested in what the number is as much as I am interested in what is it in the context of my original figure. Sir? It's the what of the top. That's not the area of the base. It's 10 plus 4 plus 10 plus 4. What does that sound like? It's the perimeter of the base.
Yeah.
Yes. So let's make sure that we're filling in these blanks together here. Okay, so that unraveled lateral faces part of our net is in the shape of a rectangle. The base of the shape is the perimeter of the prism's base, while the height of the prism is the height of the rectangle is the height of the prism. All right, so the lateral area of the prism is, as I was saying, the area of that black rectangle, which is the perimeter of the base times height. And then surface area, well, what haven't I yet included in my calculations? What haven't I yet included in my calculations? Let's look at that black rectangle. So far, all I've found is the area of that black rectangle. There's something else. The two bases, right. And what do I know about the two bases? They're congruent. Okay? So, our surface area is that P times H of the lateral area plus 2 times the area of the base. So for the purposes of your notes, you might want to add that key here. The fact that P represents the perimeter of the base and that capital B represents the area of the base. And now that we have a formula, that's what we'll be using to find the surface area of prisms here on out. So you'll notice that number 2, the problem that looks like a your turn is the problem that we're actually doing together, whereas the one that looks like a problem is actually going to be our your turn. Okay, so in the number 2 that we see on the screen, we're going step by step in the process of finding the total surface area of this hexagonal prism. First step is we're finding the lateral area of the prism. One thing I wanted to make sure to mention, look again at the reference sheet. Notice that nowhere on the reference sheet does it give you the distinction between the lateral area and the surface area. You are expected to realize, if you look at the formula on the reference sheet, there's the PH, and then plus 2B. You want to make sure that you remember that the chunk before the plus sign, and this is true for all of the formulas in today's and Monday's lesson dealing with surface area. The first chunk, the stuff before the plus sign, is all lateral area. Okay? So in problem 2 part A, where I'm asked for the lateral area, that's the P times H. Okay, remember the P is the perimeter of the base, so that's 6 times 6, which is 36, times the height of the prism, which is 12. What kind of figure is the base of my prism? Okay, let's backtrack on the vocabulary. Remember that the bases are the two congruent parallel faces. You see that the two congruent parallel faces are the two hexagons. So my bases are hexagons. That's what I'm finding the perimeter of. That's what I'm finding the area of when I'm plugging in. Sounds like I've answered your question. Okay. So 36 times 12 is 432. And then in part B, I'm finding the area of the base. Remember, we talked about it just a couple of seconds ago. The base in this figure is a regular hexagon. Remember that its formula is 1/2 perimeter times the apothem. We already know what the perimeter of this hexagon is. It's 36. What's the apothem? What is the apothem? It's not 6. It's not 3. Let's visualize it. Here it is. 30, 60, 90. There we go. It's 3 radical 3. Remember, in a hexagon, the apothem is always half the side times radical 3. Always in a hexagon. Okay, so in part B, they're asking us for the area of the base in simplest radical form. So that's 18 times 3 with the radical 3 attached. And then finally, they're asking for the surface area of the entire thing. That's, remember, surface area equals pH plus 2 capital B. Well, remember, we already found what pH was. It's here. So that's 432. Plus 2 times, again, remember, we found the area of base. We found it here. And now you're just typing all of that fun stuff into your calculator, since the instructions for part C said go ahead and round your answers to the nearest whole number. Giving us approximately 619. Square meter. Okay, as I mentioned earlier, cylinders tend to be a lot easier than prisms because their formulas are a lot more straightforward. A cylinder, because its congruent parallel bases are circles, I can't spell it. Because its bases are circles, really the only measurements that a cylinder has are the radius of the base and the height of it. As I mentioned earlier, the relationship between prisms and cylinders is very nice and neat in the sense that, remember how we talked about what happens when I cut a prism open, ladies, and fold out its lateral faces? We ended up with one very long rectangle whose base was the perimeter of the base. Consider the same idea with this. I know it's not perfect, but you get the idea. If I were to take this cylinder and cut it open along the sides and unravel the lateral face of it, what kind of figure would you be looking at? Another rectangle, and this time, Benjamin.
What was the
Who cares? The base of this rectangle is what, as far as the cylinder is concerned?
circle?
It's the what of the circle?
The area where
Well, your heart's in the right place, but we don't talk about perimeter of a circle. We talk about its circumference. Yes. The remaining shape is a rectangle, and the base is the circumference. Gentlemen, let's stay focused, please. Of the cylinder, and the height is the same as the height of the cylinder. Which means, once again, the lateral area of the cylinder would just be the area of this rectangle, or 2 pi r circumference times height. So lateral area is nice and neat, 2 pi r h. You see what I mean about how much more precise the formulas for circular stuff are. And then, remember, lateral area is just this rectangle part of it. What haven't I found the area of yet? The bases. Well, there's 2 of them, and they're both circles. So the total surface area is 2 pi r h plus 2 pi r squared.
you add pi pi squared.
No, when you add pi plus pi, you get 2 pi.
Yeah, 2 pi.
Okay, do we have from this screen what we need?
Thoughts of the week, you know,
Yes, I know. Okay, last problem I'll have time to get to. Let's wrap it up, please. In problem 3, I'm asked for the surface area of the cylinder. Remember, the formula is on your reference sheet, ladies, gentlemen. 2 pi r h plus 2 pi r squared. We're just taking the values and plugging them in. Again, cylinders are a lot easier to deal with than prisms. This will give me 2 pi times 6 times 15 plus 2 pi times 6 squared. Simplifying this, since the instructions say to leave my answer in terms of pi, I have, I believe, 180 pi plus 72 pi, giving me a final answer of 252 pi square centimeters. In this problem, you need to read the question carefully. Notice that it's asking how much paper is needed to make a label that will completely cover the sides of the can without overlap. So they're not asking this time for the surface area, they are only asking for the lateral area. And the lateral area of a cylinder is 2 pi r h. And they gave us everything that we needed, sort of. They didn't give us the radius, but hopefully you remember that the radius is half the diameter. So lateral area will equal 2 times pi times my radius of 1.5 times my height of 4.5. And when I work that out, and it doesn't say in terms of pi, and since this is a real life situation where you're not going to tell a manufacturer that you need a certain number of pi square centimeters, you're just going to give an approximate answer. We're going to evaluate the pi. So we have 2 times pi times 1.5 times 4.5, giving us approximately 42.4 square inches.